So the first argument in here is the file descriptor. When a process is getting executed and it wants to access some files, a file descriptor would be created for that process as a handler so that it could access and work with that file, read or write from or to that file. But for every process, 3 file descriptors would be created the moment that process has been created or has been loaded into memory to get executed. These 3 file descriptors are 0, 1, and 2. 0 is for a standard input for getting input from the keyboard, 1 is a standard output, and 2 would be a standard error. What we want to do in here is to print something in here on the output, so we would pass the number 1 as the first argument for file descriptor. So in here, the register that we need to fill it with the number 1 is the RDI register. So in here we say again move RDI and 1 in here. So again, when the kernel takes the control and looks at the RX register and decides that it is the right system call, the first register that it looks is RDI, or the content of the RDI would be considered by the kernel as the first argument to pass to the related system call. After that, if you look, it's the buffer or array of characters or a string that we want to print, and after that is the size of that. The 2 other registers would be RSI and RDX respectively. So in here it would be RSI and then it would be move RDX and then the number that we want to pass. So this would be the pointer to the data that we want to print, and this would be the size of it. This should be provided in the data section. So what we need to do in here is to create 2 labels. Just like variables in program languages, we want to create 2 labels. Usually in the programming languages, I create the names of the variable or labels with my name at the beginning of it to just somehow tell the people that this is not a mandatory name. Some of the time I choose the second part as a meaningful name, and sometimes no, I don't want it to be meaningful so that the people would pay attention to the variable itself. But again, as I always say, if you are doing a project, a team project or something like that, you need to specify some meaningful names. So in here I want to choose the variable of mgh, which is my name, and let's say hello. So mgh hello would be the name of the let's say mgh hello would be the name of the label that I want to put in here. If I want to define bytes, I say db in here, and now the string that we want to print, I want it to be hello world, and after that I just want to add another let's say byte in here to go to the next line when we execute it. If I open another shell in here and type man ASCII, you could see that for new line the related ASCII value is 0A. So in here I just say 0xa, and then in here we should specify the size. So I say mgh size, let's say, should be equal, this is for equal, this position that it is pointing to minus the mgh hello. Now what does this mean? Let me again open another terminal, and in here just go to a file. Let's say that this is the position that we are currently at. Let's say the address is 35, and this would be the mgh hello, all the data or the string of the, or let's say that this is the hello world, and this is the where the mgh hello is pointing to, which is the actually the beginning address of this hello world, which would be the address to which is pointing to the h character in here, and let's say the address in here is 25. Now if we want to calculate the size of this, we would say 35 minus 25. if, for example, this is the address 0 in here. So 35 minus 25 would give us the length or the size of hello world, which would be 10 in here. So again, for example, this is the address which is pointing to H. This is the address which is pointing to E. As we know, the characters are encoded using 1 byte. So if this is the address, this address is 25, this would be 26, and so on to 35. So what we have done in here is the same thing. We said that the current address minus the MGH hello, which is pointing to the starting address of H, and this would give us the size of the hello world in here. So now that we have calculated, or we have our data and also the size, we just pass it in here. So the first address for the buffer or for the array of characters would be MGH hello to be passed to the RSI, and the second one, the size, would be in here, MGH size, which should go to the RDX register. Now after we have provided everything in here, we just say syscall. This would create an interrupt or pass control to the kernel. The kernel would look at the RX register. It says, well, the process has asked to have access to or to print something on the screen, or just to invoke. Actually, it says that the process wants to access to the right system call, and then it also wants to pass these arguments. The RDI would be the first argument, which is the file descriptor. The right system call, just imagine them as file descriptor. The second one would be the MGH hello, and the third one would be the MGH size in here. But after the system call, after these things, we need to also exit. So if we look at this terminal in here, the exit system call has the number of 60. This is the number for exit. So we just do the same thing. Also, if we go to the man page of exit, it gets just one argument. So in here we just say move, again RAX and 60, then move RDI, see this is in here, RDI and 0, and then call the syscall. So this time when the control is passed to the kernel, it invokes the exit system call, passes one argument of 0, and it would get executed in here. Now our program is completely ready to get executed. Let us just assemble it and then link it to see if we have any problem in here. So I just press Ctrl O, hit enter, Ctrl X to exit, and use the NASM by passing the ELF64 in here, hello world.nasm, which is the name of it, -O to say that I want an object file to be created. I want to name the object file hello world.o and hit enter. Now we don't get any error in here, so it's time to link it. So I just say LD, which is the default linker for the Linux in here, LD hello world.o-o, and then I want my executable to be named hello world, and I just hit enter and no errors. So I want to, now this is the executable. If I press ls in here, you see that this hello world.nasm is my assembly program that we wrote. Hello world.o is our object file, and hello world is our executable. So I just say dot / and then hello world and hit enter. As you see, we have the hello world printed out on the screen.